Before we start this video, a large thank you to Ava, a name I cannot pronounce, Jose, Slim Shaggy, DJ, another name I unfortunately cannot pronounce. If someone knows how to pronounce these names in the comment section, please be sure to share. Kai Falcon, to Anthony, Max, Mattis, and Jacob for their support on Patreon. I hope you guys enjoy the video. And a large thank you to Mike Harden Games for their immense support this month, this channel on Patreon. Hello guys and welcome back. Okay, so today we're going to work on our archery system and we're going to make it so we can aim while shooting the bow. Right now all we can do is lock on and shoot or aim or shoot freely. But this episode we're going to make it so we can aim. Also we have to fix this bug too. Our speed is actually still fast if we walk from the side. That's probably a one line of code fix. And yeah, let's just get to it. So let's start by going into the input handler. Okay, so in the input handler here, you can see under player combat manager, we have handle left bumper action. Let's go check that out and follow the line of code here. So right click and click go to definition. So our left bumper action for a bow is perform an aiming action. Okay, looks good. Now let's go to that functionality in here and see what that does. What we wanted to do is just change one bool to true. Yes, but this is not the bool we want to change. So we're not going to put this on the animator anymore. So we can just erase that. So we're going to change this from animator just to the player manager. So let's actually go and open up the character manager. Let's add a bool under the combat flags wherever you want. We're going to call that is aiming. I'm going to put it right under is holding arrow here. And then on the player combat manager, what we want to do is just change is aiming to true. Let's move. Whoops, my microphone just totally lost a piece. Okay. Anyway, let's change player manager to is aiming equals true. And then if we say, if player manager is aiming up here, we can just return it. So if we're already aiming, we're not going to do that again. All right, that's perfect. Now let's go back to the input handler here. And we're just going to erase this whole little section, this if statement. Don't need this. And we're going to make it so if the left bumper is false, then our aiming bool is also false. All right, so far, so good. Now if we go into the game here, let's just test this out. It should be so when we hold down the left bumper now, that is aiming bool is true. Only when we're twinning the bow is two-handed, hold down left bumper, and yes, is aiming turns to true. All right, cool. So that works fine. Holding it turns it on, letting it go turns it off. Next, we need to actually instantiate a crosshair on the middle of the screen so you'll know where the arrow is going to shoot towards in the future. So I brought this crosshair asset in here. So I'm going to change this to a sprite 2D and UI. I have this in the source code on the Patreon page if you want the crosshair image as well. I just made it very quickly in Photoshop. So let's open up the player UI, make a new game object. I'm going to make mine under the HUD window because it is a part of the heads up display. Going to make it a new image, and I'm just going to drag in the crosshair image. Going to rename this to crosshair as well. So this is going to be very simple. We're just going to enable and disable this with like a singular line of code if we're aiming and if we're not aiming. Very simple. So let's add a reference to this image on our UI manager. So let's actually go into the UI manager now after this momentarily, and we'll add a reference to that. I think that's in the center of the screen. Yeah, it looks good. Okay. So opening up the UI manager, we're going to simply make a public game object. Going to minimize all this first so it looks a bit cleaner. Don't need all these things open right now. Okay, up here. I'm actually going to make a header too for heads-up display, just for stuff in the future. So let's make a header for our HUD. And then let's actually make a public game object for our crosshair. We have a lot of UI videos coming up in the future because we have to make sure we can drop things and pick up things and edit things from our inventory in the future. So that's probably what we're going to get back to doing after we're done tweaking combat a little bit more. All right, so drag the crosshair in there on that variable, and we're good to go. So now let's enable it when we aim. So right here, let me just go up here first and see. Okay, so we're not calling our UI manager here. Are we calling it on the player manager? No, we're not. I think we're calling it on the input handler. So let's just make this public on the input handler so we can just reference it from the combat manager. We're going to change where we actually call that stuff in the future, but for now, that's fine. All right, inputs, handler, dot UI manager, dot crosshair, dot set active is equal to true. And there we go. Let's copy that and let's paste it under the input manager here, wherever we disable our aiming bool. Actually, let's make an if statement here first too. Let's say if is aiming is true, then we're going to make it false, and we're going to also hide the crosshair. So we paste that in here and we set that to false, and then we can just move this code here. Let's also move the is blocking code here from here into here because we want to only do that once. Okay, now let's save that. That's much nicer. All right, now let's go over here and just disable this on the start so it's not on the middle of the screen as soon as we come in. And I'm just going to drag my player UI into the prefab to save the things I've changed. Okay, we got to change this to false. I did not have that to false. Whoops, let's save that. Go in the game here now, and we press the aim button. Boom, there it is. Okay, cool, that's part 2. Now, we need to make it so we actually zoom in the camera, and believe it or not, there's actually a lot to this, because we have to change the way the camera and the player rotates too, because if not, we'll actually just be circling around the player from a different point. We have to change how the camera itself rotates. So we're going to open up our camera handler now, or is it called manager? I always forget in this project. Handler. And let's go and change a couple things. Haven't been here in a while. I have a feeling my naming conventions have changed since. I'm not going to like what I see. Okay, all right, here we go. So our target position, I don't know why I used my transform.position. I should just use transform.position. Anyway, we're following the player. That's all well and good. We're going to need to make an alternative for following the aiming points when we're aiming, because we want it to go past the player so it looks like we're zoomed in. So this is all fine, but again, I don't know why I used my transform here. My transform is just equaling to transform on start, I think. So we're going to say if player manager is aiming, we're going to do some logic, else we're going to run this regular logic. So if we're not aiming, we're just going to run the camera logic, or the camera follow logic the same way, just follow the player. But if we're aiming, we want to follow a new point. We're going to put that in front of the player. So we're going to say vector3 target position, same as before down here. We're going to start it the same way. It's actually the exact same logic except for one variable. And we're going to say equals vector3.smoothDamp transform.position. I don't know why. I'm going to change that because it's bothering me. And then we're going to say, like right here, yeah, just change that to transform.position. I'm just going to delete my transform up here. And I think I called it on start or awake. I just said my transform equals transform. Okay, there we go. That was a year ago, though, so don't blame me. All right, so next, let's actually make this by a variable we don't have yet. I'm going to call it target transform. Target transform while aiming. And then we're going to have the same reference, our camera follow velocity. And then we're going to do delta times camera follow speed. And I'm going to change that to times down there too. All it means when I change it to times is that basically the lower the number, the quicker it's going to zoom in and get close enough to the follow point. So you'll want a low number. The lower the number, the faster it will perform. And then I'm just going to change this to transform position equals target position. And also this handle camera collision out here can be outside of both of these statements, but I'm just going to make this variable up here first. So right here, let's actually get some organization up here too and start naming things. All right, so I'm just going to put a comment here saying the transform, the camera follows, then brackets the player. So this is just the follow target. It's going to follow the player, obviously. And then let's paste another one down here. Whoops, didn't mean to put that line of code down there, or I mean that comment down there. Let's call this target transform while aiming. I'm just going to put a comment here too, rather saying the transform, the camera follows while aiming. Because you can walk away from this for a long time and come back to it, and if you don't leave comments or the naming conventions aren't clear, it's kind of confusing sometimes. All right, so that looks good. Let's actually make that transform now. So you want to parent it under the player. Actually, what have I got an error here for? All right. What? Did I not use that? Okay, I guess I didn't use the name. Let's paste that. No, I'm a fool. I didn't put dot position. You can't convert a transform from a vector. Okay, so that should be target transform while aiming dot position. Okay, that's good. Let's save that. Do we have any more errors? Let's see. Yes, we do. We have one more. Let's double click that. Here we go. Just replace my transform with transform. Again, don't know why I did that. Okay. We are good, I think. Yes. So let's actually go over here now to our player. I'm actually going to tweak the speed. Like I said, the follow speed, the lower you put it, the quicker it'll follow your character. So I think that looks all right. 75 feels pretty good. Let's try 50. Yeah, 50 feels really good. Okay, we're going to go with 50. I just had to edit that real quick. There we are. All right, so let's go to the player, and you want to right-click on her. Make sure it's under the player. This is important. You have to parent this transform under the player. You'll see why in the future part of the video, so I'll explain why. Let's make a new transform for the camera. You can put under combat transforms if you want, or you can give it its own header. Anyway, just call it, I forget what I called the variable, so let's call it aim camera follow transform for now. I'm going to call it the same thing that the variable's called in the camera. I'm going to position that a little bit ahead of my player. Let's go back to the camera handler. Okay, yeah, so it's right here. It's called target transform while aiming. Just going to call that the exact same name as the variable, so if I ever lose track of what these things are in the future, it's very easy to know because my variables have the exact same name. All right, so back to this handle camera collision thing. We need to actually update the transform here, so make sure you say transform position equals target position, and we can actually update the camera's collisions outside of both these statements because that's true regardless of if you're aiming or not. All right, that looks good. Now, if I go in, you can see we can zoom in here. Looks pretty cool, but oh, that's the problem. See, we're facing ourselves there, and this actually happens right now because the way we have this set up, we need the character to rotate in the direction the camera is facing, because what we want to do is actually rotate this target transform piece here while aiming. So I'll just show you, and if we go in here, we're going to need different rotations. Basically, right now the camera rotates by rotating the camera main object. I think that handles the Y rotations, and this is the camera holder itself. And then the camera pivot, so the Y being left and right, the camera pivot handles the X rotations, being up and down, if you follow me so far. And then the camera object itself, it does not rotate at all. But we need to change that. We're going to actually change what rotates here and how it rotates, because this camera setup and these rotations only work if you're following a person in third person, not when you're aiming a weapon. So let's actually make a new function that's going to choose how we rotate our camera based on certain parameters and flags. So if we're locked on, for example, if we're aiming, etc., etc. So let's make a public void. This one's going to be public because it will be called on the player manager. We're going to call it handle camera rotation. And then we're going to actually, we're going to rename these other functions, and we're going to clean them up a bit. So this one is going to be handle standard camera rotation, and we're going to delete this float delta and these floats that we need because we can just reference them from the input manager. Then we're going to make a private void. Let's make one for handle lock camera rotation. Okay, and then let's make a private void for handle aiming camera or aimed camera rotation because it's going to behave differently no matter what one of these things you go into. Okay, looks good. So let's up here, let's say follow the player. I'm just going to comment some stuff here too. And I'm just going to put a comment here saying rotate the camera. I need to mute the Discord. Sorry about that. Let's make a thing here for handle collisions. And let's just call this lock on or handle lock on. All right. There we go. Now, let's actually open up this functionality. You can see here, okay, so if our lock-on input is false and we don't have a lock-on target, so up here we're just going to say if input handler dot lock-on input is false and current lock-on target equals null, then we're going to say handle standard camera rotations. Else if player manager is aiming, we're going to say, we're actually not going to include the lock-on target right now because I need to test this further, but if we're aiming, so the lock-on takes priority over all else. You'll always face the lock-on target if you're locked on, which is ideal. Then we'll say handle camera rotations, aimed camera rotations. And lastly, this one right here will be handle your standard camera rotations. Okay, so this one right here is not working because it wants me to actually send you or send the details of X and Y on the mouse. So let's copy and paste this logic here and paste this into handle the camera locked rotations. We can delete that float. Don't know why it was there. It's not necessary. All right, this looks good. Now this is the standard rotations, so we can actually copy the logic from here, and let's take it out of the if statement. So just copy it, remove this if statement, and paste it. And now instead of calling upon this float and the delta, just erase all of that. We can reference these from the input manager. We don't need to do that there. Okay. For some reason, oh, did I call it something else? It's input handler. Man, I always get those names mixed up. Too many projects happening simultaneously. Okay, there we go. It's not called mousex input. It's probably called mousex. Yes, it is. Excellent. So let's copy this here and put this here for mouse Y. Now, I don't like the names look angle and pivot angle because only I know what that means, and I feel like to anybody just watching the video, Not going to know what that means. So after we change this delta to time.delta, we're probably going to change those two. We're going to change it to something very simple. So simple you can never mistake it after reading it. That's going to make sure this is good. Yes, very good. Okay, excellent. I feel like I'm missing something here. Anyway, up here. So pivot angle and look angle. Okay, our pivot angle is up and down. I know that because we have a limit to how much we can look up and down. So we're just going to call this up and down angle. Very straightforward. You'll never mistake that. Look angle, left and right angle. That's it. So now you know you're looking left and right with this, and you're looking up and down with the up and down angle. Pivot speed can be up and down speed. We can even call it up and down look speed if you want. That's a better name. And look speed will be left and right look speed. Okay, perfect. Very, very easy to understand. Minimum pivot and maximum pivot can be changed to maximum look up and look up angle. And this will be, you can change it to maximum look down angle if you'd like. Maximum, I'm just going to call it look up angle. There we go. It would be better name it look down angle though. But that's okay. Okay, so handle aimed camera rotations. First, what we're going to do is say transform.rotation equals quaternion Euler 0, 0, 0. We're zeroing out, resetting all of our rotations when we come into here. Because when we come into the aiming transform, we want to make sure everything's reset. Then we're going to say camera pivot transform.rotation. We're also going to zero that out equals 0, 0, 0. We don't want any rotation there when we first come in here. Because, again, it's different when we rotate with our regular camera because our regular camera rotations, because we're going to change the rotation on the pivot and on this game object up here. But we're going to actually rotate the main camera as well inside this function. You'll see what I mean. So now if I go in here, let's make a quaternion target rotation X and a quaternion target rotation Y. So let's go in here then and say vector 3 camera rotation X is equal to vector 3.0. We'll start off at a 0. We're going to say vector 3 camera rotation Y is equal to vector 3.0. So the end game goal of this is to rotate the camera object and the parent object of everything. So the pivot won't be using this at all. Normally we use the pivot. So then we're going to say left and right angle plus equals input handler dot. Oh goodness, I can't remember if this is mouse X or mouse Y. We're gonna say mouse Y. I think this is mouse X though. Times. Then we're gonna say left and right look speed. And this is aiming speed, so we want to make it slower than normal speed. So you have two things you can do here now. You can actually just divide that by something like 3 or 2 and times it by time delta time, like that, and that will work out fine. But I'm going to do this one better, and I'm actually going to make an additional variable to actually handle the speed if you're aiming. Also, these numbers are so low because we fixed the bug in a previous video, if you recall, where we were actually dividing our time delta dot time and not multiplying it. So the look speed and the up and down speed are very low. We're going to fix that too. They have to be much higher. Let's actually initialize the left and right aiming look speed at around 5. Probably going to need to make it much higher than that, but we'll keep it there for now. So we could say input handler dot mouse Y times left and right aiming speed. There we go. Oh, I forgot. I need to raise that bracket. Okay. So next, let's do the same for the up and down speed. So we'll say up and down angle equals minus equals input handler dot mouse X. I think it's supposed to be mouse Y. I have this feeling in my gut. Times up and down look speed. And then we're going to times that. Actually, we're going to make another variable for that too. So it'll be up and down aiming look speed times delta. Time dot delta time. All right, so let's go up here and make that variable. This is going to be a long video, I think. I still have about at least 10 minutes of content to cover. Might have to get to some of the other features in the next one. Up and down aim looking speed. And let's initialize that at 5 again. That's going to be too low of a number, I think, but we'll try it anyway. Don't want it that slow. We'll say up and down aiming look speed. Okay, good. Excellent. So then we're going to say camera rotation. We'll start off by saying camera rotation Y dot Y is equal to left and right angle. So we want to basically make the camera look left and right depending on the left and right mouse movements, okay? Obviously, and up and down with the up and down mouse movements. So we're going to say target rotation Y equals quaternion Euler, camera rotation Y. And then we're going to say target rotation Y equals quaternion slurp. It will be transform rotation. And then that will be by target rotation Y. So we're moving from our current rotation to our new rotation at a speed of 1. You can make a variable for that if you'd like, or you can use the camera look speed. I'm just going to say 1. Then we're going to set that to our transform local rotation equals the new transform rotation. So basically we're taking the Y rotation here, that will be the left and right from our input, and we're assigning it to this game object's Y rotation. So looking left and right will move this camera object left and right on the left and right rotation. And there we go. Next we're going to do the X. We'll say camera rotation X equals, we're going to say up and down angle. And then we're going to say target rotation X is equal to quaternion dot Euler. And then we're going to say camera rotation X. And then we'll say target rotation X is equal to quaternion dot slurp between our current transform, but it's going to be the camera object, or this will be the camera object dot local rotation dot target rotation X by 1. And then we're going to say camera transform or camera object is equal to, do I reference that up here? Yes, so it's just called the camera transform, okay. Then we're going to say camera transform dot local rotation is equal to our target rotation X. So we want the X rotation on the camera object itself and the Y rotation on the parent object. We're not using the pivot at all in this one. Over here we can erase the need for this now. We can say handle rotation. This is on the player manager. There we go. We can erase this delta on the follow target too. Let's go to that. Let's just erase the delta and use time by delta time. Not a fan of this either. How I pass the delta along. I just don't like doing that. You can keep it if you like. I'm being, just my conventions are my conventions. I'm a stickler for it sometimes. There we go. And let's paste this down here. Excellent. Okay. Whoops, there we go. And erase that from here. Excellent. And then we can erase that from here as well. And wherever we request the delta here, let's just put time by delta time. Okay, I think we're good. Now we're missing something. Hang on here. We're going to say if current lock on target does not equal null, we're not going to do anything here just in case it somehow gets past that. Let's paste all this in here. Let's save that. Oh, and I made a mistake right here. This should be if lock on input is true, and if the current lock on target is not null, handle camera lock rotations. That's my bad. Okay, so let's go into the game here now. And you can see here, these variables here for left and right look speed, they were set to these old variables. So let's change these in here too. When we actually added new parameters here, it actually took these old values. I don't know if you remember in the last video, we set these to something like 250, not 0.1. So if you did this and now you can't move your camera, your rotation is not broken, you just need to reset these variables. So unless you're going to change all of these to suit the newer fixes. These are fine, so let's save that. Okay, so the follow speed, again, is fine at 1. And everything else, these look left and right speeds, 250 I found was a really good number. And I'm going to set 25 to the up and down aiming speed and the left and right aiming speed. And I'm just going to drag that camera handler into this prefab. Okay, so if I go in the game here now and actually aim the bow, you will see moving the mouse from left to right makes it go up and down. So I got my values backwards here in the handle aim rotations. It should be, coming down here now just to open it up, let's go down here. It should be left and right angle is equal to mouse X, up and down angle is equal to mouse Y. And then we'll save that. Now let's test the rotations to make sure we're good here. Now if I go into the game and approach this man and lock on, we are not locked on for some reason. Okay. Oh, we're not supposed to lock on flag, not input. Make sure you don't put in lock on input. That's why. We're checking for the flag, not if we press the button. And that should be good now. Let's actually copy that and take it outside the if statement. We don't need it there. We're checking for it before we go in. I just realized that. Now, if I go over here and lock onto this man, it works normally. No lock, and we're locked. Okay, cool. Now, if I aim at him now, we should also be able to move the crosshairs up and down and left and right. Yes, okay, the speed is very slow, but that works just fine. Works very good. There's a problem, though. And I'll show you in a second, but we're going to fix that problem immediately. Let's set up the speeds. I'm going to change those to 100 because that's probably still going to even be a little bit too slow, maybe not. So if we go into the game here now and we see the view, we can see the camera right here. It just looks at our player. That's cool. And if we aim, you see it looks at this point in front of us. What we want to do is we want to move that point as the camera moves. And to do that, we got to move the player so the player is always facing the camera. Oh, and also this should be camera transform dot local rotation, not camera pivot transform. Otherwise, the slurp doesn't work and the transition looks rigid. Anyway, in handle rotation, let's go and figure out what we're doing here. So the goal of this basically is to just make it so when we move the camera, the character faces in the same direction of the camera while you're aiming. This will in turn move that point we assigned inside the character, which the camera will follow, making it so the camera always faces in front of where the character's looking. So this point right here, we want to move this thing as we move the camera left and right. And to do that, we have to move the character in the same direction as the camera, which makes sense because while you're aiming, you're obviously looking in the direction that you're aiming. So let's make it so while we actually move the aiming camera, we always have our player facing in the direction we're aiming. So right here, we're going to say if player dot manager dot is aiming is true, we're going to do some logic, else run the other normal old rotation logic. We always want to make sure we can rotate first though, so put that inside there. Let's just copy and paste this whole thing. This is all the old rotation logic that deals with our rotations if we are locked on. If we are not locked on, this is all still fine, and we're just going to place it inside this else statement here. Now, if we are aiming, we're going to do things a little bit differently, and it's very simple, only a couple lines of code. Let's start off making a quaternion. We're going to call this our target rotation. It's going to equal quaternion.Euler, and we're going to say 0, and then we're going to pass the, this is called camera handler in the script, camera handler dot camera transform dot Euler angles dot y and 0. And then we're going to say quaternion player rotation is equal to quaternion slurp between the transform dot rotation and the target rotation. And we can do that at a speed of the rotation speed times time dot delta time. And we're good to go after we assign the rotation, which we'll do by saying transform dot rotation equals player rotation. Now that should work, I'm pretty sure. Should be fine. Let's save that. Now we go into the game. We aim with the bow, and you will see, boom, there we go. Whenever we turn around, we're facing this direction. You can change the speed if you want, so the camera catches up to the player a little bit faster. I kind of like it, adds a bit of a sway. It makes it so your aiming is a bit more, it takes a second to get focused, and that looks fantastic. Okay, so next we're going to actually make it so we can shoot. So when we shoot at what we're aiming, rather, the arrow actually rotates towards it. So this will be the center of the screen. So we're going to make a thing here saying if player manager is aiming, else. Now, normally every time, let's put this in the else, every time you're aiming, you're going to be aiming at something. You might just be aiming at the sky, but most of the time you're actually aiming at something. So we're going to do two things here. We're going to make it, we're going to use this should be look rotation right here. On the if camera handler dot current lock on target is unequal null, it should not be transform dot forward from your player because if they're on a hill, this won't work. It should be look rotation camera handler dot current lock on target dot lock on transform minus the live arrow dot transform dot position. So change that, or else when you're locked onto something that's on a hill or below you, it will not work. Okay, and after that, let's go up here now to the is aiming, and we're actually going to use a ray cast from the center of our screen to get a direction to rotate the arrow. So we're going to start by saying ray equals camera handler dot, and we're going to say, well, we need to make a camera object variable here. So let's actually do that. We can't use the transform, we need the camera itself. So on the camera handler script, let's make a public camera object variable. It's of type camera. There we go. And we can call that on awake because obviously the camera sits below this on a child of the game object. So we'll say camera object equals get component in children camera object. Whoops, not camera, camera object. And we're going to use a function basically to pinpoint the center of our screen, shoot a ray from the center, and then wherever the ray hits, we're going to rotate the arrow towards that object. So we're going to say here ray equals camera handler dot camera object dot viewpoint to ray new vector 3 0.5f 0.5f and then 0, and that will be the screen center because it's half and half. And then we're actually going to say, or we're going to make a raycast hit variable. And we're just going to call this hit point. So this is whatever the raycast hits or touches. And then we're going to say if physics dot raycast, we're going to pass our ray out hit points. We'll say at a distance of 100 is fine, I'm sure. Because if you're not, at that point, you're shooting into the air. And then we'll say live arrow dot transform dot look at, and then we'll say hit point, and that's it. So there's only one problem with this, and that's if you're looking directly into the sky, you have nothing that the ray is contacting. But we can remedy this by just actually using the camera rotation x value instead. So we're just going to say here in the else statement, we're just going to copy this line of logic here and paste it. But we don't want the camera pivot transform, because while we're aiming, we're actually not using the camera pivot. We're rotating the camera object itself. So we wanted to make sure the more the camera object is looking up, which is the X rotation, the more we give more rotation that way on our arrow. So we're going to simply change camera pivot transform to camera transform. I think it's just called camera. And we want to make Euler angles local Euler angles X. So basically that means if your raycast hits nothing, we're going to rotate the arrow depending on how much you're looking up, not on what you're looking at. So that'll be fine. Let's save that. And this when we come to contact, we're looking to the sky. So if I aim right now up at the sky, like just up here where the raycast hits nothing, just above this, you'll see it'll shoot up, and it will fall as it begins to fall. If I aim at this character's head, it shoots it right at the head. Now, an alternative to this, which I might do, is just basically getting a direction from the raycast direction itself, so that way it's always consistent. But the only way it would be different right now is if you aim at the sky or there's nothing that your raycast aims at. But right now, there you go, guys. You have a fully functioning aiming system and archery system. In the next episode, we're going to polish it a bit more. We're going to add arrow penetration. We're going to fix that walk fast bug. And we're just going to do a couple more things with it and clean it up nicely. So, as usual, if you made it this far, don't forget to drop a like. It genuinely helps out my series so much. Leave a comment to appease the YouTube algorithm gods. And if you're feeling super generous, check out my Patreon below. And I will see you guys in the next one.